Hello there, a new day, a new project. So I have this laptop batteries. I don't know anything about the shape of this, but what I'm trying to do is to open them up and to recover the cells. So for this one it's like 6000 milliamps. That should be a good one. How can we do that? First of all, I'm going to try to twist it a little bit. And I could feel some reaction over there. Let's take the label. Okay. So these are looking pretty okay, but there's something wrong over here. I can see these elements are compromised for sure. This was very easy. So we have like 1, 2, 3 cells already compromised. That's not good. Let's take this off first time. The label. Oh, this one is looking much better. Okay, twist it a little bit. So let's find the vulnerability over here. I think it's the same charging port, charging and data port. That was pretty easy. You know, I always text or a piece at least, because then it's much easier to solder the wires. If you can, you just keep them. The last one is this Aces. Label off. Twist it a little bit. The vulnerable place, it's here. So never push into the batteries, always go up. That's it. And there we are. Perfect. I can call it, this is a 6-pack too. So my AMX is here, ready to do the first charging and discharging cycles to see about the capacity. But the first thing I'm gonna do, I'm gonna start measuring the internal resistance. So if we have a couple of milliohms, then it's worth the effort to do some later job. But if not, I'm gonna recycle them. Please never ever throw this into the trash. There are special recycle points to every supermarket or mall or whatever, so never put them in the trash. Okay, so let's start with the green ones. This is a really nice machine. It's checking the the voltages and the internal resistance. Very nice. What? 92. Okay, that's kind of gone. Okay, by the way, let me show it. Okay, I know this one are pretty okay, so let's check one of these. 54, 55, you see, so we should have less than this to really working the things. Yeah, let's say around 55, 50 maybe. So as low as possible. Let me check these two. They are in parallel. So we should have like maybe 25. I don't know. Let's see. 46. They are pretty big too. Let's cut this. So when you cut these tabs, always start with minus and then do the pluses. This is a thermic fuse. It can be useful someday. So I said that should be around 90. Oh no, 66, 66, but 0 volts, nothing, nada, no voltage. These are good. 0 volt, 0. Anyway, I'm gonna try to charge them to see what is happening. What about this? 175. Oh no, these are for sure shorted. These are shorted for sure. What we got here? We have some thermal fuses, of course. Nothing here. Maybe this one. Yeah, so these are compromised. It's nothing to do with them. Okay, so it's time for testing. I have this homemade charger. I'm gonna use that too. But in the meantime, the most important tool over here, it's my IMX. So let's say we have this two now, charging with 4 amps to 2 amps for each of them. That should be okay for you see, now they're saying low voltage. How can we fix that? Simple. We change the menu, go let's say to nickel, okay, nickel metal hydride, 4 amps, and then the machinery think this is a nickel metal hydride batteries and starts pushing the voltage and current into these cells. So we keep it like this for a couple of minutes until the voltage is rising to a certain value. So we need 4 volts or something, and eventually back to lithium or lithium polymer charging, and it will be an answer over there. So this is a kind of trick, I may say, how to wake up the cells. Okay, let's try again. Go. And there we are. No more problem about low voltage cells. That's a kind of trick. That's it for now. I hope this was fun. It was a lot of fun for me. And hopefully that's something to learn from here. Until some new projects, wish you well. Be safe. Bye bye.